Okay, so we'll start with the ggplot. So last time we did, this was the last code. Last uh, week we discussed how to make a scatter plot, two variable. So today, what I'm planning is I'll do a single variable, um, just one variable, and understanding the distributions of one variable. So in univariate case, typically these are called univariate case, and when you are handling two variables, that time it will be called bivariate case. So last time when we did this, let me just run this piece of code. When we did, when we took the empty cars data set and plot the horsepower and miles per gallon. So this is typically two variables we are considering, and horsepower and miles per gallon. So the distribution of horsepower itself uh, will have its own distribution. Miles per gallon will have its own distribution, and then jointly they will have their own distribution. And what I mean by joint distribution of uh, of bivariate distribution, what we really understand by joint distribution. So let me explain you this a bit. Okay, so let me copy this part to a new thing. I'll just copy it, only this part. uh, okay, so we have this we have this ggplot2. So one thing we can do is we can draw a histogram of, say, miles per gallon. Okay, so how can we do that? So let's first write ggplot, and then data equal to empty cars, comma. So aesthetic, we have to give the variable name mpg, and then if I just run this part, this part, then you will see that miles per, it only gives the framework miles per gallon, and um, then we have to add the, so it just gives the my basic foundation, and then we have to add a geom histogram, and we have to give some bandwidth. So bandwidth equal to, say, 5. So it draws the bandwidth. Okay. Mm, Okay. Next is I'm just trying to play around with the bandwidth here. Why it's, I think there is something new. Stat bean. It's asking me to use beans or stat beans. Okay, I can maybe I will use a stat bean instead of histogram. Stat bean, and that will probably a better. I don't know. Pick better value with bandwidth. Acha, sorry, not bandwidth. It will be bin width. Sorry about that. Yeah. So now if you choose a bean width, which is 10, and then you can see that only you got only 3 bins. All the data falls in the on these 3 bins. Now each bean is defined somewhere between, I think, 5 and 15, then 15 to 25, and 25 to 30. Now if it is 5, if you do the bean width, then it is probably from 7.5 to 12.5, and then 12.5 to, I think, 17.5 or something. And this way they're defining the bean width and running the histograms. Now, one thing you notice that the y-axis, it's plotting count. Okay. So that means basically the frequency. It's a frequency distribution plot. And so if you want to do a density plot, so then what you can do is something like this. So one advantage of is you can put it into an object. So this is the advantage of using a object oriented language. You can put this as a object, and then you can say that, okay, my P is, so this is, if you delete this, let me delete it. Now, if you just, so P is only the backend, and then if you draw the P and all these things, then, and now what you can do, as I said, that ggplot runs on a layered system. So instead of this way, you can say that, okay, I will just take the backend, and instead of this way, what I will do, I'll just make, say, geom. So geom stands for geometric histogram. And then what I will do, yes, y equal to, now this is very specific. And then I'll say bean width equal to 5. And then what you can do, you can put this on another thing. So now you can see previously it was count. Now it is density. Okay, and scale is also now at a density. Okay, so that you can do. And then what you can do is P plus. So let me, I want this entire thing, and then I want to little bit play with it maybe. So I can put it into another object. Okay. And then call this object and say that, okay, x lim means limit of the x-axis. That stands for x lim. Say C, I want to give a slightly larger limit, maybe 5 to 40, whatever you want to give, but you may have to little bit play around with the limit. Similarly, you can try, say, y lim. See here, it is somewhere between 0 and 0.07. So maybe we can just give C between 0 to 0.1. Okay. So, and this x lim, y lim control is actually helpful when you are doing the comparison between, say, two group of histograms. Okay, so that time control on the x-axis and y-axis and giving a proper limit scale so that you can compare the true scaling effect. And then what I can do is I can add a density curve on that. So what I can do, I can put it into, say, P2, okay, another object P2, and I call it, okay, I'll just say P2 plus maybe geom density. Somebody is writing something. So what is the use of y dot dot density? What purpose of the dot serves here? To be honest, I really don't know what purpose of the dot here. My educated guess, it is being defined in this way. It's a function, built-in function, where these double dots before the density is a part of the definition of the call, the function name call. That's my educated guess. So geom density and say color equal to blue, maybe. So you can see that density is being drawn. Now, if you want to change this color, remember that this color was done here. So you can do it here actually. Or you can do it here also. I'm not sure. Let me try. So it should be fill. Correct. Do it in this way. So it is kind of this, and then so that is what it's doing. So So this is the histogram and a density over the histogram kind of thing. So now this is when I'm analyzing only single variable, but if I'm analyzing two variable, now you can think of something like this, that my miles, if I have to, this here, what I'm doing, I'm putting the miles per gallon on the y-axis and horsepower on the x-axis. Now, if you ignore the horsepower, then what will happen? This point will be projected here on this axis, and this point will be projected here in this axis. So all these points will be automatically on this y-axis. Correct? Are you guys with me? So all my points are on this y-axis. Just I'm trying to say that for the, suppose I'm not considering the horsepower, I'm ignoring horsepower, then all these points, which is on the 2 dimension, they will be on the 1 dimension, only on the miles per gallon. Okay. And then you can think of these as grids. So between 25 and 30, how many points? 2 points. Between 30 and 35, how many points? 4 points. Between 25 and 20, how many points? 1, 2, 3, 4, 5, 6, 7 points. Between 20, the maximum number of points, maybe 14 or 15 points. So that is how we create a bin and we create the frequency. And then if I have to draw, you can think of, I can draw a small bar here. I can draw a small bar here and a small bar here. So that will be my histogram. Okay. So that will be my histogram of miles per gallon. Now, similarly, horsepower, you can think of that if you completely ignore miles per gallon, then and only consider horsepower, then all these points will be projected on the horsepower on this x-axis. Then you think of as if 50 to 100 is one bin. So how many points are there on the 50 to 100? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the frequency between 50 to 100. So I will draw a bar like that. Or I can just draw a bar like that, like here. Okay. And then 100 to 150, I'll draw another bar like this. Then 150 to 200, I'll draw another bar like this. So that will be the histogram of the horsepower. Okay. Now, let us consider this horsepower and miles per gallon together. Okay. And this is the grid that we can think of. Each box is my bin I can think of. Correct. So these horizontals are the grid of the miles per gallon or the y-axis, and the verticals are the grid of the x-axis or grid of the horsepower. So each of the box is my beans now. So for this particular, let's concentrate on this one particular bean. How many points are there in this bean? 3 points. So I can say for this bean, the frequency is 3. Right? For this bean, frequency is 3. For this bean, its frequency is 5. Now, if I ask you to draw a histogram on these beans, where you will draw the frequency, the bar for the frequencies.
So 3-dimensional.
Huh?
3-dimensional in the z-axis.
3-dimension, absolutely correct. So you will need a z-axis. You can imagine that bar is coming out of your screen to yourself, correct?
Yes, sir.
So that is what, and that will be like a hill. And that hill is the probability, joint probability distribution, or the joint distribution of horsepower and miles per gallon, or X and Y. The joint, that you can imagine that hill is your joint distribution or joint probability distribution of X and Y. Okay. So we will draw 3D plot, but not today. Okay. Now, I'll do a small, I'll do a small detour actually. So I just want to today, last time I did the scatter plot. Today I want to do the histogram and the pie chart. So I want to complete the basic things, and then I'll go into the 3D histogram. That will be maybe next week. Okay. So before that, the 3D histogram. So I think what I will do is pie chart. Is so I'll take the, I'll look into the, let us look into the empty curves data set. So the first variables are all continuous variable. Now pie chart, when you do pie chart,
When there are some proportions.
Like proportions, that means your variables are categorical variables, correct?
Yeah.
So variables are some kind of categorical or string you can think of. So last few variables, like whether it is a V-shaped or not, 0, 1, okay, whether it's automatic transmission or manual transmission, whether how many gears the car has, how many carburetor the car has. So I'll take the gears. We can think of gear is sort of a factors, categorical cases in this case. Okay. So, or cylinder, we can take the cylinder also actually. Yeah, we can take a cylinder also. So cylinder is cylinder distribution. first thing first, table empty cars. So I'll take the cylinder. Empty cars dollar. When I do the empty cars cylinder, it gives me all the vector of all the variables. And then if I just do a table of that, it gives me the table that there are 11 observation where or 11 cars in the data set which has 4-cylinder design. There are 7 cars which has a 6-cylinder design, and there are 8 cars which are 8-cylinder design. So, and then what I will do, I'll just put it in data frame, because I'll do some operation later which are easier to do in data frame. Nothing special about this. So now, but when I put it in this data frame, so it has changed its name. So I have to put all names. Frequency, I will keep it as frequency. So now if you just, so now the, okay. So this is the frequency table of the 4 type of cylinders. Okay. Now I can draw a pie chart of that on a pie chart for these categorical variables, the proportions on the proportions. Okay. So how can we do that? We can first is here I have to provide the data, which is this one, this object. And then this is bit of a interesting thing. Here I don't have anything on for X. Y will be frequency, and you have to give fill as cylinders. That's how I figure out that typically it works. So if you just do that, it will just create a first layer or foundation layer, which says that, okay, my X is sort of empty and Y is my frequency. Okay. And then if you just say, now I'm going to add the second layer with the bar plot. At equal to identity plus identity width equal to 1. If you just run this, so now it's draw a simple bar plot on the same thing. And then what I'm going to do is there is something I'm going to make it. This is now Cartesian product. Okay. And now I'm going to make it polar. With Y, which starts from 0. Now if you run the thing, so now it's creating. So basically it took the bar plot, it treat the bar plot as a Cartesian product object, geometric object. It transferred it into a polar coordinate object. So that's how I mean, that is where it easy to remember for me. then what you can do is certain, I think this is more like a beautification kind of thing. Theme void. So if you do that, so it just delete that thing, and then you add another layer on the scale fill brewer. Is take the palette, palette equal to set one. Uh, so this is the plot that we are getting. Now, if you change set 1 to set 2, you will get another palette. So it gives you different color combination. Now, if you try set 3, it will give you completely another thing. If you try set 4, I think there are only 4 sets are available. So this is like within green, different kind of shades. So I think there is no set 5. Let me try it out. Yeah, there is no set 5. It's saying unknown palette. So we have to figure out only maybe 2 or 3. Yeah. So so you have to little bit play around with the aesthetic and settle down which one looks good, good not, and all these things. So good to the eyes. Now, okay. All right. So now what I'm going to do, I'm going to do one more thing, and in the distribution. So first thing I will do is I'll compute the percentage. Compute the percentage, because remember that I was working directly on the numbers, the frequency itself. But
Sir,
yeah,
so can you do one thing? Can you just scroll up a bit?
which one?
Yes, sir. What happens if you interchange X and Y?
I don't know. We can try that. Let us try that.
Sir, if we, I think if we remove like X and I mean interchange X and Y and then remove the stat identity, then also I think it will be the same.
It will be same. Okay.
So,
if you so if you remove and it will still same, that means that is the default setup. Okay. But if you remove this, say if you remove this and it's still, if it is still works fine, no, it's not working actually. So you need to give it give something X, what is X and what is Y. Okay. So yeah, but I think if you change the order, I don't know if that makes any changes or not. Let me try that. No, I think polar coordinate is important to give that, so that it will make a pie chart looks like. See, I think in every version, they change a little bit. Sometimes, so probably before when you worked on another version, maybe it worked, and then they may give some change a bit the arguments. Okay, so what I'm going to do, I'm going to compute the percentage. All right. So what I will do, I'll write a frequency or fraction, maybe. Fraction. Frequency divided by sum of frequency. Okay. So this is now my fractions, or the proportion, more correctly if you say. And then what I'm going to do is I'm going to compute the cumulative percentage. And what I'm going to do is cumulative percentage is effectively I'll call it as Y max, and there is a reason for why I will call it Y max, and you will figure out in few minutes. Just hold your patience. Cum sum. So I'll do it as a frequency, correct? Yeah. So I'll just copy this. This way. So now if you run it, so now this is actually cumulative percentage, okay, or cumulative proportion. Now what I'm going to do is I'm going to compute the Y mean, and I will require this Y mean, and you will understand what I mean by this Y mean once I calculate this. Basically, this is 0, comma, n equal to -1. So if you just run this, if you do that, now you can understand what I have just done. So basically, I'm trying to say this cylinders, the percentage is between 0 and 0.34, and then I'm creating 0.34 to 0.56, and then 0.56 to 1. So this continuous, I want to create a sort of a bar, you can think of a continuous step function kind of thing. So it will go from 0 to 0.34, from 0.34 to 0.56, and then 0.56 to 1. So I want to create this kind of a continuous spectrum. between 0 and 1. Remember that it only makes sense. It only makes sense if your categorical data is ordinal. Okay, because I'm inherently assuming there is some sense of ordinality is there. But if the categorical data is not ordinal, like if it is color of the car, how many cars are red, how many cars are blue, how many cars are black and silver, then this will not be a good thing to do. Okay, and I'll tell you what and once I plot this, then you will understand exactly what I have done. And this plot is more suitable for ordinal categorical variable. Simple pie chart is good for even nominal categorical variable. Like if I say this is red, this is purple, this is yellow, this is green. These are the three type of colors of car are available, and these are the ones which are available. Then it is okay. You can do it in that way. Pie chart is something which works very nicely for both um, uh, nominal categorical variable and ordinal categorical variable. But ordinal categorical variable has some sense of ordering, and I want to capture that sense of ordering in my plot. That is what I'm trying to do here. So whatever I'm doing, it is doing it from the book ggplot2 by Wilkinson's. Okay, so all right.
Sir?
Yeah.
Sir, what is this Y mean? I did not understand.
I'll once I show that, once I'll now make the plot.
So this Ymax function is returning some error in my computer.
Okay, just a minute. Let me just draw the plot and then I'll look into your one. Okay.
Okay, sir.
Yeah. So let me just explain you what is this Ymax and Ymean. So Ymax is, so the first is data is equal to test. Okay. Then Ymax equal to Ymax, Ymean equal to Ymean, x equal to 4, should be comma, and x mean equal to 3, and fill equal to cylinder. Cylinders. Okay. If I just do that, then this will give me the basic plot. And then what I'm going to do is add the layer. First is geom rectangle. So first, if I do that, then what it tells me. So on the x-axis, I have to give some kind of, starting 3 to 4. It would be perfectly fine, I think, if I give 2 to 4 or something like that. I have to give some width for that, which is slightly artificial, but that's okay, I think. Now, if you look into the data set, the cylinder 4, which is the pinkish color, start from 0 that is the minimum, ends at 0.34. So it starts at 0, ends at 0.34. Then the cylinder 6, which is green color, starts at 0.34. That is the minimum for 6 cylinder, and ends at 0.56. So that is what it is. It starts at 0.46, 0.34, ends at 0.56. Similarly, the 8 cylinder one, which is the blue one here, it starts at 0.56, ends at 1. It starts at 0.56 and it ends at 1. Okay, but this kind of ordering works only if your categorical data is ordinal categorical data. If some sense of ordering is there. If it is like good, very good, average, this kind of categorical data, you know there is a sense of ordering. Then it makes sense. Okay. Acha. Next, what I will do, I will add another layer. I will basically make it polar coordinate kind of thing. And here I have to give theta equal to y. I don't know if I change it to x or something, what will happen, but for the time being, let's take it. So now it's like the same thing, but I'm presenting in a polar coordinate manner. So it's starting 0 from here. It's going up to 0.34, and then 0.5 is here, and 0.34 is starting the 6 cylinder, 0.34 to coming here to 0.56, and 0.56 to meeting at the 1. So which were previously bar plot like this, going from bottom to top. It's now I'm doing the same plotting, but doing in a polar coordinate manner. Okay. Now, if I add another layer, I think if I just say, I don't know why it makes that. I don't think it required, but some reason it was there. So I'm just putting it there. Okay. So it's making the thing. So same thing, but it's just deleting the middle part. Okay. Now it doesn't look like a pie chart. It's called donut chart. Okay. It's just a special kind of pie chart. Effectively, it's a pie chart, but again, the same thing, starting from 0, going clockwise at 0.34, then from 0.34 to going 0.56, and then from 0.56 to 1. Okay. And so now one thing you can do, I think there is something called theme void. If you add that, some of the background will be deleted. Yeah. So some of the backgrounds are deleted. And then you can add the text also. X equal to 2. Okay, for the adding text, I have to create a label position. All right. So So where I will add the text, so that position I have to say here, that in the thing. Okay, so let me quickly do that. Okay, so in the distribution, be position is equal to, what it has done is, okay, y max okay, and then I have to give the label position. So if you now, so I'm basically saying that oh no, I think they're divided by 2. So basically saying that around 0.17 he write the labeling for cylinder 4, 0.45 we give the labeling for this cylinder 5, 6, something like that. So I have to give the label position as y, and then of course label equal to cylinders, color equal to cylinders, and here size equal to 4. So you can see you have got it like this. If you just give maybe 7, you may get a little bit much of thing. So, and many things actually you can do. So effectively it's picking up 468, this one, because I have given label equal to cylinder, this one, but whatever you will write here, so you can write full sentence, 4-cylinder with whatever, and then 6-cylinder, any text that will be considered as a text, and it will be picked up and shown here. Okay, all right, I think that is good enough for today. What time is it? Okay, it's almost 11:30. So let's stop here for today here. Okay, I'll anybody have any question? Let's do some discussion if you have. I think Shivli, you said you had a problem. Did you able to fix that problem, or?
Yes, sir. Yes, sir. There was a variable issue.
Okay, all right.
And sir, can you please show that label position line?
Wait a minute, let me share it. Which one? Label position. Okay.
Yes, sir. I just wanted to see the function.
I'm just taking the max, mean, and taking the average of the max and mean, basically. Okay. So far we have discussed scatter plot, histogram, density over histogram, pie chart, and donut chart. And I'll see, probably I will introduce the 3D histogram next week sometime. And I'll see what else are there we can do. But one thing you remember that there are a lot of options are there. I myself also don't know many of these options. So it's kind of, sometimes it's very difficult to, keep up with all these new coming option, new features and all. They keep adding features. So So it will be better if you keep trying the value, change the value a little bit here and there and see what happens. So if something is X, you change it to Y, see what changes is happening. If there are any changes are happening, stuff like that. Okay. Okay. If you don't have any question, we can stop today's.
A mail 2 days ago. I was having this problem with ggplot2 installation. It didn't work.
Okay, I remember. You still have this problem?
Yeah, when I you said the last day to install that R install and DevTools, and those two also didn't work. R install it was okay while installation, but while installing DevTools, I got the same warning message regarding the exit.
Okay.
So
Acha,
I have sent you the mail. I mentioned it.
No. I remember that. Yeah. So let's maybe sit separately of the time. I'll you drop me another mail right after the class. I'll check my schedule and I'll
Okay, so it
also
will not be possible for me to sit tomorrow. Maybe we can do it a day after tomorrow.
so
Any day
you
after that.
give me your availability at 2-3 slots. I'll see which
Okay.
slot I'm available and I'll try to schedule a meeting and I'll try to fix that problem. Meanwhile, this reminds me one interesting thing I would like to share. Let me share my desktop. So if you go to your Gmail account, and typically if you go to Google Drive, in the Google Drive, if you just click on new, and then here there is a more, there is something called Google Collaboratory or Google Colab. Okay, so let's open it up. So this Google Colab is effectively a Python. You can all effective purpose. It's a Python Jupyter notebook on Google Cloud. Okay, so but interesting thing is there is a development version of Google Colab Python where you can run R code also, and I have I think I have a notebook, but which is not by default setup. I don't think it is available. I'll just check it out. Okay. Okay. In fact, you can choose a GPU, TPU, or none means it will be normal computer. And tools, palette, things. Yeah, by default setup, it will be a Python notebook. But I have some using R also. So I have this Colab notebooks where I have written R code also. The advantage of doing it, you don't have to really worry about. So you can write notes. You can write notes here. And like this, you can write LaTeX notations also very nicely. And then here you can write the R code also. And R plots and everything comes. So what I will do, I will create a R notebook for using Google Colab. I'll share it with you guys. So through your Gmail account, you should be able to access it. And I'll share the link so that all you have to do, you have to save the notebook or copy the notebook in your Google Drive, and then you just run it. And then on that notebook, you can even add or subtract also. So meanwhile, so this is a nice option for all of you guys. in case you are facing any problem with the installation and all, you don't have to really worry about installation. And most of the time the installation, if you need to, here also you may need to install a R program or something like that. Like I have done some installation, but generally you don't have to worry about the the version and all these things. So those works pretty nice actually. So I have done a lot of things in these things. So I have both R code as well as Python code. So this is library. This is my R code, and I think this is Python code. Yeah, these are my Python codes also. So, okay, I'll share this with you guys. And Samantha, maybe you just email me
Yeah, sure.
availability and we will try to fix it. We'll see if I can help you anyway. But this is a alternative backup that you can use. This Colab notebook. Okay.
Okay, thank you.
Sure. Okay. All right, guys. Thank you.